Hello Year 10, welcome back to your rivers lesson. Before we get going with new content today, a time for a bit of revision, a bit of reflection. You've got 5 minutes. I'd like you to write down and brain dump everything you can remember about rivers from before the holidays. You're going to do that from memory, and then I'm going to go through some of the key terms with you in 5 minutes. So pause the video now. And here we go, some answers for you. Well, a variation on some answers, because what you've got here is a key term list. As you'll have found out previously, there's a lot of key terms in this topic. So everything from the long and cross profiles through the different processes of erosion, transportation and deposition, all the different landforms you've learnt about. We shall be coming back to those in a minute. And then loads of other words describing certain parts of a river and its valley surrounding it, describing what goes on in the river, the sediment in and around the river. It goes on and on and on. So there's a list for you there. Double check through in just a second and add anything that you missed out. It's also worth spending with a good 10 minutes here, spending some time going back through and checking definitions. Now, I've not got time to go through every single definition here. That would be the lesson done. So time yourself to 10 minutes, do as many as you can. Don't worry if you don't get it all done. It's not likely that you will have managed to get the whole topic done in just 15 minutes. On the right there, you've got some hint questions to think about. Number one, as I've already said, you have all these words. Do you know what they mean? Really, really important. No point in knowing a word if you have no idea when and where and how to use it. So definitions for those words would be great as well. What can you add to your brain dump with these words? Yeah, you're going to do that now, hopefully. And finally, there's going to be a textbook section, a PDF attached into class charts at any point in this lesson, and there'll be moments where I ask you to use it. You should get that open. So now will be a good time to get that open, ready to go for later as well. But you can also use that to check through what you've done so far. So 10 minutes, check your brain dump, please. Pause the video now. Okay, well done. Good job. The title for today's lesson I'd like you to write down is Landforms of Deposition. We've covered landforms of erosion and transportation. Today, deposition. Don't forget the date. Give those objectives a read through and make sure that you have all the equipment listed there. It should just take you 1 minute. Pause the video now. So, as I started already saying, context. Over the last lessons before Easter holidays, you learned about the upper and the middle course of a river, the erosional landforms in the upper course, and meanders and oxbow lakes, which were made by erosion and deposition in the middle course. Today, we're going to move to the final section of the river, the lower course, and the different features there formed by deposition. And by that point now, we've covered all three of our main river processes: erosion, transportation, and deposition. So if you look at this photograph, this is a photograph of a floodplain, and it's also a photograph of something else we're going to be studying later, but we'll come to that when we come to it. Just to show you, this is the bank of the river. I won't go all the way, but that was a little bit inaccurate there, but there we go, you get the idea. Here's the other one. I'm drawing this with a mouse, it's a little bit fiddly. There we go. So that's where the river is. Everything inside those red lines is the river. So where's the floodplain? Well, you've got some very clear flooded land. You can see one kind of area this side of the river to the left on this photograph. On this side, you've got a very long area flooded all the way on this side. So this is the floodplain. Surprisingly enough, it is where the river floods. It is flat. It is it can be as wide as it needs to be. It can be wider than this if the water levels were even higher. More and more of this flat land either side, more of these farmers' fields would be flooded. But this is a floodplain. So before you move on to the next slide, please follow that link and have a little watch of that video for me, please. You can pause the video now, watch that, and we'll come to the next slide in just a second. Okay, so hopefully that video has helped put this all into a bit of context and made sense to you. You can always go back to it if you need to help answer these 5 questions. So page 121, please, on the attached PDF that I asked you to open earlier, the textbook sections, and I'd like you to answer these 5 sentences in full sentences, please. It should take roughly 10 minutes to do so. You can get going with that now. Pause the video. Okay, some answers. So a floodplain is a wide, flat area of marshy land found in the middle and lower courses. They're made, the sediment itself is called alluvium. And it's very small sediment, and it's deposited when the river floods. Linking into the third question, the process is deposition. This is all about the dropping of that very small, fine alluvium, this very fine sediment in this part of the river on the flat land that we expect. If you remember back to the cross profile of a river, the flat, wide valley that we expect to find in the lower course. Then we move to D and E, the two different explanations. Now, what I've written here is a fairly concise and brief version of these. I'm going to go into these in a little bit more detail in a minute, and then allow you some time to add any more writing and perhaps even some diagrams to what you've written here. So, D, meanders migrate across the floodplain due to lateral sideways erosion. We've learned that before. When they reach the edge of the floodplain, they erode the valley's sides. There's something new. We'll visualize that in just a moment. For E, flooding deposits silt or alluvium or that small sediment, lots of different words for the same thing there. Every time the river floods, it deposits more silt, and this builds up over time, raising the floodplain. It also helps to flatten it out. But let's have a look at those now. So you can see lateral erosion occurring here. In diagram A, you have your river flowing down its course. In diagram B, you can see as the meander has increased in size, the floodplain, that flat land either side of the river, has increased in size. And you can see, hopefully, the shape of the floodplain kind of reflects the shape of the river. Around here, we've got this bend. Well, that's because of the meander that's carved that away. And over time, as this meander moves and kind of snakes its way across this floodplain, constantly changing its shape, eventually we end up with C, and you can see that wide now flat land. We've gone from A with a very narrow floodplain all the way to C with a very wide floodplain. And also you can see there some oxbow lakes being formed and meanders continually migrating as that floodplain gets bigger and bigger and bigger. And that's why, in this case, due to lateral erosion, we may see flat floodplains on either side of the river. Okay, we move on to levees now. Now, back in the video, they mentioned levees. Levees and floodplain formation kind of go together. You don't see levees everywhere. You certainly don't see levees on every single floodplain, but you can be sure that if they're natural, then they're formed from the same processes. Yes, you can have human levees. They're known as embankments. You will come to them later in this topic as a management option of how to try to reduce flooding. So hopefully you can see here the levee. The levee itself is this raised bank. The bank here is raised, and you can then see it slowly descending down on that side there. So that's the levee. The levee is this raised embankment or this bank down the side of the river, found usually hand in hand with a floodplain. So back to the PDF, back to the textbook, and back to page 121. Hopefully it's still open there. You've got 3 questions to answer. Should take at the very most 10 minutes here. For C, please include a diagram as well. Get that pencil out and draw and illustrate how a levee is formed, as well as some writing to go along with it, using as many key terms as you can. You've got 10 minutes. Pause the video now. Okay, some answers. So what is a levee? It's a raised riverbed found alongside the river in its lower course. B, it's made of small fine deposits, the same small deposits that we talked about previously on the floodplain, but it's formed by flooding over many years, many repeated floods. And a ridge of sediment is deposited naturally to build up the levee. As the coarser, slightly larger sediments, and when I say slightly larger, I mean in comparison to the other small sediments. These are all still small sediments. I'm not talking about boulders or even pebbles here. I'm talking about very small, very fine, think sand and smaller size sediments. And as the river loses its energy, if you remember back to the video, you may have also included one of the reasons it loses energy is because of friction with the vegetation, with grass, with other plants. As it moves across the ground, it slows down, it loses its energy, so it deposits the sediment. The largest sediment being deposited first. The water still has enough energy as it's losing it to carry other smaller sediments. But as the water moves further and further away from the river, those sediments get smaller and smaller and smaller until eventually the river can't carry any more at all. So if here's my river channel, here are my normal banks. As the river floods, as the water moves out of the channel, the sediment is going to be deposited, the larger sediments first, and they're going to pile up. Remember, not in one flood. This is not something that happens in one flood and suddenly, bam, there you go, you've got a levee. This is going to take place over multiple floods. This could take a very long time to form. But then after that, you're going to get slightly larger sediment, and it's going to get smaller and smaller as you move along, until eventually you're left with the absolute finest of sediments there. And there we go. We have our levee shape, our mound of earth on the side of the river. And yes, the river itself therefore can actually raise in height if there's a levee on both sides. So if there's a levee over here as well, the river can now flow to a high level. So this is almost a natural way that rivers kind of, without knowing obviously, but they can balance out the risk of flooding. The higher the levees go, the lower the risk of flooding is, because there will also be deposition possibly occurring at the base of the river here. So if the river gets higher and higher, as the river's bed gets higher and higher, so do these levees, and you find that the land is essentially rising. As the floodplain gets higher, so does the river, so do the levees. It all is going up. Hopefully that makes sense. And there's a diagram, or probably you could draw a slightly nicer version than mine, but there's a diagram you could have included with your answer to C. Okay, so estuaries. Our final depositional landform on the lower end of a river, and this is found right at the very end. It's found at the mouth of a river. Here we go. Here's our river channel. I shall mark that in red. There's one bank, there's another bank, and you can see it getting wider and wider and wider until eventually it opens right up, and at some point this becomes the sea. Now, you'll also notice, I hope, that there is some deposition going on here. You can see in this area here some form of sediment. This looks like sand from this distance, muds and sands, and it probably is. Now, this material has been transported here from the river. This sediment has traveled down the river. This is our fine silts and alluvium, whatever you want to call it, our fine sediments that have been gathered all the way along the potentially hundreds of miles of this river, and as they reach the sea, they are deposited here. Why? Well, you're going to read the book to clarify this again in a minute, but the main reason is because of a loss of energy. Guess what? Same thing as with all deposition, it's caused by a loss of energy. Why does the water lose energy here? Well, you've got the river flow going one way. You've also then got currents and tides of the sea itself going this way and going in all sorts of directions. So in this area in the middle here, this zone is a place where the water loses its energy. Goodbye energy. There we go. So any sediment being carried may get washed out to sea, obviously, but it also may start to be deposited, and as it builds up and up and up, the water gets shallower and shallower, meaning that deposition occurs even more frequently as the water above it loses more energy, and it can build up and build to form this. Well, it's known as a mudflat, and it is often seen, and if you've been down to the coast and you've seen where rivers meet the sea, these are very frequent. You will see these a lot, often revealed at low tide. Sometimes at high tide these can be covered up, but they are very important for all sorts of marine and land creatures. Birds go down there to feed. Many marine creatures live in those sands and muds as their habitat. Yes, blah, 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 blah. So, page 121, once again, you should see some information on estuaries. You've got 3 questions to answer, 10 minutes in full sentences, please. You can pause the video now. Okay, so an estuary is a transitional zone between the river and the coast affected by both wave action and river processes. Deposition is the main process occurring here. And to summarize, during the rising tide, water is unable to return to the sea as the river's velocity or the speed falls, sediment is deposited. If you go back to my explanation on the last slide, there's a little bit more to it that you could add to that, but there is a very succinct version of the answer. Make sure you've got that down. Okay, so that's it. The 3 landforms completed there. We've got floodplains, we've got levees, both of those linked together very much just like meanders and oxbow lakes were. And meanders obviously included as one of the explanations for floodplains as well. So hopefully you can see now how all these landforms, a lot of them are interconnected, similar processes. One landform can lead to another. So if you were asked to explain the formation of a floodplain, you could absolutely explain how meanders and why meanders change shape and move as part of that answer, as long as you link that into the flat land either side of a river and the shape of that adds to a very detailed answer. So thank you for completing today's lesson. Have yourself a lovely day, and I shall see you all next time. Goodbye.